Hello, welcome back to Statistics and Mathematics YouTube channel. Today we are going to continue our series of videos on probability theory. We are going to tackle independent bivariate random variables. We have two types of independent bivariate random variable. We have one for the discrete case and one for continuous case, and both of them will be inclusive in this particular video. The first on the list is independent bivariate discrete random variables. So what does it mean? The discrete random variables x and y, so here we are assuming them to be joint, that's x and y, are independent if and only if the joint probability of x and y, right, is equal to the marginal of x times marginal of y. It's either you use the p, you can choose to use the p, or you use what, the f, right? In any ways you are not wrong, so don't get yourself confused. Okay, the only thing you have to work for is to just calculate for your margin of y and the margin of x. When you multiply the margin of y by the margin of x, and then that multiplication is equal to the joint, then we can say that the joint probability distribution is what, independent. Okay, yes, so that is what we are discussing about. So let's solve some questions. So when we come here, you said the question is saying that the joint probability mass function f bracket open s comma y of the discrete random variable is given by 1/21 times 2s plus 3y, where our x is equal to 0, 1 and 2, and y is equal to 0 and 1, right? Is x and y independent? That is the question we have to solve. Is x and y independent? So how are we going to solve that? So you see that this one is a discrete case, so you have to calculate for our margin of y and the margin of x, right? And we learned that for it to become independent, our joint must be equal to the margin of x times the margin of y. So for this one, we are saying that marginal of y is equal to 1/21 summation, right, where our x move from 0 to 2, of which for here, right, so for margin of y we are just going to sum on what, the x, right, on the joint, so that we remove the s component from it and the end result will contain only y. So when we sum on x, this will be the expression, right? So here we are going to work for x equal to 0, s equal to 1, and s equal to 2. So when our x is equal to 0, anywhere we see x, we put in 0. So that's the reason why we had 2 times 0 plus 3y, right? Here our y will be constant, and then when our x is equal to 1, we put it here, and we get 2 times 1 plus 3y. And when our x is equal to 2, we put it here, 2 times 2 plus 3y. So that is what we have, and then we add everything together, we get 1/21 bracket open 6 plus 9y to be marginal of y. So what will be marginal of x? For marginal of x, we are going to sum on y. Okay, so you are going to get 1/21 summation of y moving from 0 to 1 of this expression. So anywhere we see y, we are going to substitute either 0 or 1. So here, if our y is equal to 0, right, if our y is equal to 0, we are going to get 2s plus 3 times 0 plus 2s plus 3 times 1 when our y is equal to 1. And when you add everything here, you are going to get 1/21 4s plus 3y. So that is what we are going to get here for y and then for x. Okay, yes, so for it to become independent, we say that this one, right, must be equal to marginal of x times marginal of y. The joint must be equal to what, the multiplication of what, the marginals. Okay, so once you multiply the marginal, we saw it clear that the multiplication of the marginals does not equate to what, the joint. So therefore our x and y is not what, independent. I have more question here that we have to solve. Okay, this question says that we have x and then y here, y component, right? On the 3 we are going to add everything, on the 4 we add everything here, on the 5 we add everything here, on the x section here we add everything, to get both the rows and the column, both the marginal of y and the marginal of what, x. Okay, yes, so the question is saying that we should use the table to detect if our x and y are independent. Okay, and then that solution is down here. So here we have all our marginal of x, then we have all our marginal of y, and then all the probabilities that you see inside here, are joint what? They are joint probabilities, right? So I'm trying to say that if you have the joint, if you have, let's say, f of x which is equal to 0 and y is equal to, let's say, something like 4, we are getting the probability of what? 1/8. So they are all joint, right? Let's say if our x is equal to 1 and then our y is equal to 5, we are getting 1/6. So we have been able to get 1/8 and then 1/6. So they are all, so when you keep on doing it, you can see that they are all joint. So we are just going to take one of these, right? We are just going to take one of these and then get the probability and then calculate for our marginal of x, which is equal to 1, and the marginal of y, and then just multiply if you are going to get 1/6. That is all the meaning that this question is trying to let us understand. So here we are just taking one of them, probability that our x is equal to 1 and our y is equal to 4. And when we come here, s is equal to 1 and y is equal to 4, we are getting our answer to be 0, right? So we are also to check if probability of, we are also to check for probability that our x is equal to 1 times probability that our y is equal to 4. We are also to check if it will give us 0. So let's check for that one. Probability that our x is equal to 1 means that we are going to get marginal for our x is equal to 1, and the answer is what? 12/24. So we are going to get 12/24 times probability that our y is equal to 4. Here we have that one here, that is 6 divided by what? 24. So you could see clearly that 12/21 times 6 divided by 24 is not equal to what? 0. So hence x and y is not what? Independent, right? We can also choose to use another way to solve it, right? If you take, let's say, f bracket open x equal to 0, comma y is equal to 4, we get 1/8, right? So what's the probability that our x is equal to 0? So probability that our x is equal to 0 is 6/24. What the probability that our y is equal to 4? We see clearly that it's also is equal to what? 6/24. So you see that 6 times 6/24 times 6/24 is not giving us what? It's not giving us 1/8. So still you see that it's not what? Independent. So in this case, you can just choose one of them to disprove that x and y is not what? Independent, but rather they are what? Dependent. Okay, yes. So that is for the discrete case. Okay, so for continuous case, we are saying that let x and y be a random variable, a joint probability density function, and the marginal probability density function of x and y are given respectively. So x and y are independent if and only if, right? The same thing as we discussed earlier, right? If and only if the joint probability density function f of x comma y is equal to the marginal of s times the marginal of y. If when we multiply them they are equal, then we can say that they are what? Independent. Okay, and then we have this question here. This is the question we have already solved. Okay, they said determine whether the random variable with the following joint probability density functions are independent. We are just to determine if it is independent. So for it to be independent, first we have to get our marginal of y and the marginal of x, right? Of which you have already solved that question. Okay, so here our marginal of x is equal to 4s bracket to 1 minus s squared, and the marginal of y will be 4 times y cubed. Okay, when we multiply this one, marginal of s and the marginal of y, we are going to get, so here f of s comma y is equal to f of s times f of y, that is 4x 1 minus x squared times 4y cubed. When you multiply this one, we are getting 8xy cubed 1 minus s squared, of which you can see that it's not equal to what? 8y. So they are not what? Independent. Okay, so that is all that we want you to really understand at this section, right? In our next video, we are also going to discuss the expectation of functions and then conditional expectation. That is what we are going to treat in our next video. So if you haven't subscribed, kindly subscribe to Statistics and Mathematics YouTube channel so that you get more understanding on that. Thank you. Bye. Have a great day.